I'm going to talk a little bit about how I believe AI innovation can accelerate impact. And obviously, we're in very exciting times. So I've been at Google now for 19 years. Actually, most of my time was in product development and search, and my roots are in research. And what we see today is the ability for us to drive technology and to drive research in a way that accelerates what we can do in every field in our life. It's more exciting than ever. And on that, actually, what I'm particularly excited about is what I call the magic cycle of research, which is really, when you think about scientific research or technology research, it's really driven in, you can think about intellectually driven research, or you can think about curiosity-driven research. But what I'm really excited about is the kind of research that is driven by the kind of questions that are going to make a difference. I like to call it also sometimes intentional curiosity. And it's really about identifying a problem, looking into what needs to be done in order to unlock it, have the research which we'd like it to be according to the scientific method and often be published in the right places, but then take it back and apply it to solve problems. And this is something that we've been through history again and again. By the way, even some of the greatest mathematicians, some of the questions were motivated by questions in physics and chemistry, and then applying them back. What we see today is an acceleration of this cycle, and one of the exciting things about being in Google Research and leading it is really the fact that we're set to do that in the best possible way. So what are we actually looking into, and what's really top of mind when I think about what are the areas that I really care about? Obviously, the opportunity to have impact is as broad as it gets. It's starting with foundational machine learning and algorithms. It's about generative AI foundations, which of course, generative AI is now through a transformation that impacts everything that we do. It's about applying AI for accelerating scientific discovery itself, AI for science. It's about addressing some societal challenges and opportunities. And we have the exciting area of quantum, which is, I'm going to touch on that very briefly, but again, if AI is one of the driving forces for a lot of what we do, when we think about one of the biggest opportunities for the future is about quantum computing. So when we think about the level of problems that we'd like to tackle, they're actually going from a planetary level to societal level to human level to computational to cellular, again, across the board. So I'll give a few examples of why I believe that we are set to accelerate impact in such a big way using AI and innovation, and of course, platforms that we have and products and so forth. Let me start with the Generative AI Foundation. So obviously, Generative AI is going through a transformation, and now, of course, everybody and their cousins will tell you this is the case. Of course, now we are all experiencing it, all aspects of life. It's not entirely new from, for ourselves to look into that. In fact, when we think about some of the evolution that we've gone through in the past few years, and transformers, for example, which is one of the technology that enabled the current revolution, was developed in Google Research in 2017. And we had since then many other milestones of language models. And our most recent one is Gemini, which is used across. It's a multimodal model, foundational model that actually brings together all modalities of text and images and videos and enable to do magic. And we see, of course, across the industry, many other great foundational models. The thing is that what we thought is going to be kind of difficult or impossible just a few years ago is now taken for granted. And the pace of innovation keeps exceeding. In fact, when we look into our current model, the way to get where we want to get is actually through the entire stack, anything from the infrastructure to the research, to applying to the models and testing, and of course to the products and the platforms that then serve anything from, in Google it would be anything from search to YouTube to our phone, and of course through cloud to any player that can then leverage on those in multiple ways. And the models themselves, of course, making progress all the time. We're really excited about the fact that on all these metrics we have in the right place of the measurements and the benchmarks and keep driving progress across along with the industry. Now, one of the questions I got a lot in the last year was a question of scaling laws and where do we see that heading and how are we thinking about the next level of progression? Importantly, of course, one thing that we discovered is that when we take these models and we make them bigger, actually we make progress. But there's so much innovation actually going through the development of these models, making them more efficient, more factual, enabling reasoning layers, enabling thinking, making them actually much smaller and still better. So the notion of innovation is not stopping. In fact, this is always true. One thing that was always exciting to be in research, and I remember that since my early days in Bell Labs many years ago, is the ability to actually take a problem that is hitting a wall and then coming up with new observations, new techniques, new ideas, new algorithms, new approaches that suddenly don't make it 10% better or even 10 times better, but can make it 1,000 times better. And this is really exciting. And what we see in innovation, a few years ago, I was speaking a lot about what I call ambient intelligence. Namely, can we use AI in a way, in our experiences, in a way that we actually forget that we're using technology, that it's just there. Of course, we experienced that with Google, where you kind of learn to just Google thing, right? You don't necessarily think about all the technology stack behind it. You just expect that you just search for something and you find it. And similarly now, you expect that when you have text, suddenly perhaps you don't remember if you read it or listened to it. And soon enough, you're actually going to remove all the barriers of cross modalities and cross languages. It's just going to be there, and you were just going to take it for granted that it just works. And to me, this is one of the magic of technology and magic of AI. So a few examples of such new approaches, something that I really love this because we worked so much on that. When we looked into large language models, one question that we asked ourselves a few years ago, can we actually be more effective on them? And so let me describe one such work that we did on our team called speculative decoding, essentially based on the observation that in many large language models, for many of the decoding of the next token, what we call, in many cases, actually a smaller model will do pretty well. However, there are cases where you do need a large model, which is much more expensive. So speculative decoding is working on a scheme that we have what we call a AV is difficult, yeah. Now it's back. So the draft model is one that actually runs much faster and computes those next tokens. The second observation is that actually if we do a few kind of predictions, we can actually take a big model and in parallel right now test some of those predictions right now. So what you see illustrated in this figure is really how this draft model running and the big one checks, and once in a while you actually need to apply the big model. And the beauty is that actually the result is as good as the original one, except that it can be much faster, actually by a factor of 2 to 13, and more efficient. So it actually saves energy. And by the way, what we see on the left-hand side is these kind of what it means when something is twice faster on the experience. So that's an example of an approach that turned out to be not only very effective, but turns out that it was actually basis for by now hundreds of follow-ups and variations and various ways to do these drafters and actually implement this prediction even into the bill model, etc. And many innovative ideas that actually building on the framework. And again, this is an example for how to use a different approach to actually unlock an opportunity. And there are going to be, I'm sure there's many, and there are many other techniques actually to make the systems more effective. And to me, the more exciting ones are those that we actually haven't seen as yet. And when you think about it, actually, there are implications not only on experience, etc. I mentioned that this actually saves on efficiency and energy. Recently, we actually looked into what's the energy consumption of using a query, using these prompts on the Gemini. and looking into the entire stack of more efficient model architecture, efficient algorithms and quantization, and all of those. And these actually provide a significant factor of improvement on the efficiency. And as we know, energy is one of the bottlenecks in today's LLMs and today's AI, generative AI. So this is an example of where innovation can actually drive through, and while making progress on the quality of what we compute, we can actually also getting better outcome altogether, as well as more effective and unlocking some of those opportunities. So that's an example for innovation on generative AI. And again, there's so much more work to be done, anything from doing them multilingual to make them more factual. And again, factuality, or the opposite of hallucination or grounding, grounding in factuality to address hallucinations is something that was a pretty big problem out there, a couple of years ago. And now actually most models are getting into a level that you can trust them in a much better way. And it's an active area of research that we're working on, and also across the industry. So I think it's pretty important. Let me switch to AI for science. The notion of science is obviously in the heart of a lot of what we do in all disciplines. And I'll give you a few examples where AI can actually help scientific discovery itself. So we're not talking about how to increase it, how to multiply it by a factor of 2. The opportunity is really to multiply it by by order of magnitude, by actually amplifying scientific discovery on its own. So again, we already see a few proof points over the last few years, notably AlphaFold, which by now already was the basis for Nobel Prize to my colleagues, Demis and John, is already such a system that accelerates scientific discovery. So AlphaFold actually solves the kind of problems that used to be the subject of a dissertation, a single dissertation to do AlphaFold discovery and to do a protein folding kind of solution. And now we have millions of people actually working and using AlphaFold to accelerate their own discovery on that. And that's an excellent example for acceleration in this particular field. Let me give a few other examples. So one is a decade-long collaboration that we have with Harvard called Connectomics, which is try to understand the structure of the human brain. So taking a cell, a tissue of a size of half of the size of a grain of rice, and having the full analysis of that. It's essentially providing 1.4 petabytes of data, which is equivalent to 18 years of 4K video. Looking into all the 16,000 neurons, the 150 million synapses, and enabling through a system to actually explore that. So that's kind of giving visibility to researchers on that. Or this is the structure, but also looking into the function of a brain. In this case, actually making the whole brain activity data set and benchmark of a single cell resolution for the larval zebrafish. Something that we published actually is called ZapBench. Again, these are kind of tiny steps, literally, because if you look into where we are on this brain tissue versus what we really need to understand, we're really in a tiny step. But it's an important one because suddenly the experts can actually now have access to kind of information that we haven't seen before. Or if we're talking about the function of the brain, one fascinating question is how do we actually do our next word prediction in the brain? How similar or dissimilar is it from our known LLMs? So in an active research, actually, for past few years, in collaboration with researchers in Princeton and NYU and Hebrew University, we're looking into those questions, actually showing that in many cases there are striking similarities between how the next word prediction within the brain versus the next word prediction within large language model. However, there's also discrepancies that are actually motivating some additional research, which I think is quite fascinating. Now, one of the most exciting opportunities that I see is really how can we help AI in a generic way to amplify the work of any researcher. To that end, we actually put together what we call AI Coscientist. It's essentially a system with AI agents who are playing the role that typically you would expect from research assistants. Starting with literature search. So AI, of course, has no boundaries to the kind of literature search they can actually look into. But beyond that, then creating hypotheses. So the way it works is that the researcher is posing a research question to the system. The system then does the relevant literature search. Then it actually creates some hypotheses and tries to then validate them to the extent possible by the AI system, given the knowledge that it has. Now, importantly, to rank them, because you can generate actually as many hypotheses as the system can actually produce. So ranking is a really important problem as it is in search. Ultimately, what is more interesting to look into, and then bringing it back to the researcher and iterating on that. Now, this is kind of conceptually, I think it's pretty natural. Interestingly enough, even in early research results that we had on that, we already saw some encouraging findings. For example, we saw that with the help of such a system, and these are published results in collaboration with researchers in Stanford and in Imperial College London and others, we saw some new target for liver fibrosis. We saw some hypothesis for drug repurposing for AML. Drug repurposing is really important opportunity because it takes approved drugs and actually finds the right way to actually use them for other conditions that were not anticipated before. And it found, for example, and this was with Imperial College London, that were pretty stunned with this, the insights for bacterial horizontal gene transfer and antibiotic resistance. So they took a problem that actually they worked for years. They came up with a hypothesis which was not published. And in a collaboration testing the AI Coscientist system, actually the system came up with that same hypothesis in just a couple of days. I would add a caveat that the system, even though the research took years and it was not published, the result, there was a lot of progress in the literature, so you cannot, we need to remember that it already also took into account some of the additional new findings that it has. And the team is working actively in partnership with many others to look into, for example, can we find any new insights on ALS? ALS is, as we know, notoriously difficult problem. And the question is, can we actually leverage on the power of AI to actually do more on that? Now, I find it quite encouraging because this is the early days of using this system. And I envision that it's going to have huge impact into the future. Let me touch on a few other examples. When we think about the opportunity to take AI and to solve some of the biggest societal problems, the opportunity today is greater than ever. Actually, it's not only an opportunity. Let me start actually with the legacy work. This is using AI circa 2016, using AI of machine learning, of analyzing a picture. In this case, it's a picture of the retina, in analyzing it in order to diagnose a condition called diabetic retinopathy. We have about 400 million people with diabetics around the world who are actually at risk to get diabetic retinopathy that can lead to blindness if not treated. In fact, this is perhaps the #1 treatable cause for blindness. Now, if identified, you can treat it. Problem is shortage of hundreds of thousands of experts to actually do the job. So in a seminal paper that was actually selected as one of the top papers of JAMA, one of the leading journal venues, in 2016, we found out that an AI can actually do at the level in par with experts. Now, it's one thing to have scientific work. In order to really bring it to reality, you need to do a lot. In fact, we've even published some of our findings. And what does it take to take such an AI result and bring it all the way to clinical reality? A couple of years ago, I was actually visiting a clinic in Bangkok, which the system is already in use. And I saw in my own eyes, no pun intended, how a patient comes, sits in front of a camera, and 2 minutes later getting diagnosis that indicates whether or not they need to have a follow-up treatment. And by now, we had over 600,000 such screenings that can actually save people from blindness, and already have agreements of getting to up to 6 million screenings in the next decade. By the way, interestingly enough, it's not only the ability to actually help out the healthcare system to actually have the diagnosis, which is important here. As I learned when I was visiting there, in previously, only 1 in 5 who actually was supposed to then go and have treatment actually did it because they got the results only a few weeks after the visit. And we know the weakest link in treatment are humans. Turns out that if you get the result on the spot, most people would actually take the treatment. Another example, which I'm really excited about, so when large language models started, obviously the big question is how much can we use them and how much can we trust them in the medical domain where we cannot afford to have hallucinations, we cannot afford to have errors, there's a price for that. So to that end, we actually looked into the question, can we take a large language model? We started with what we had at the time, which was Palm. Can we actually train it? Can we actually fine-tune it, as we say, in order to do a better job on medical information? And the then surprising result was that we could actually get into a pretty impressive result. In fact, for the first time, we had a large language model that could pass the US-style medical exam in a passing score, 65%. This was a big deal then. But the pace of progress is such that by the time that work was published in Nature, we already had a language model, Gemini, that could pass it in expert level. In fact, 91%, expert level is 85, and 91%, and also take modalities, take images, CTs, and actually provide helpful information on that, which is quite encouraging. By the way, this is not a doctor yet because they don't have the full qualification of doctor. The way I'll say they are actually better in these exams than probably most doctors, but I don't know they are passed yet the high school exams in the right level. So there's more work to be done. But think about how helpful it is. In fact, in the pace of this magic cycle, by the time we had this paper published, we already had actually one of the biggest healthcare providers in the US already testing the language model to see how they can incorporate it into their system. And in fact, just a few months ago, I was visiting the innovation hospital of HCA in what they call change management. It turns out that actually there are hundreds of thousands of reports, end-of-shift reports, which currently are done typically by people taking notes. And you can imagine what happens if some errors are there, what the implications are on people's life. And actually by using these language models to help out with the reports, you can actually not only save time, make the healthcare workers happier, but also reduce errors, which can save lives. So that's an opportunity, that's an example of how incorporation is. And again, this is to me just the beginning of actually doing that. The more other approach to look into how can we help with healthcare is the question of diagnostics. Can we use AI, almighty AI, to help the practitioners, the physicians in that? And in a sequence of research papers, in fact, we published a couple of papers in Nature, actually the same issue of Nature just a few months ago. What we showed is that if you have a primary care physicians using AI to assist them with the interactions of diagnostics, in fact, the scores that we got in most axes were actually higher than doing it without AI, including on helpfulness and empathy. And just recently, we actually published another work that we're doing with our partners of how to have guardrailed AMI. AMI is the name of the project, which stands for Articulate Medical Intelligence Explorer. And the idea was, can we actually have a system where actually the system, as it provides the assistant, it's guardrails by the actual person. So it's really about how to use AI to empower the primary care physicians in this case, in order to get better results, more effective, and high quality. Now, when you think about how to empower others, one thing that is always on our mind is how can we actually provide a platform and systems for others to innovate, to build on. And to that end, we developed and put out what we call MedGemma. Gemma is actually the open source version of Gemini. It's an open source which is highly popular, very effective, very powerful. MedGemma is the most capable open model for multimodal medical text and image comprehension. And we put it on what we call the Health AI Development Foundation, which essentially is a platform that we did for health models out there so that we can have other third parties, startups, researchers build on that. And it has pretty impressive results, these models. They're quite effective, but also it's quite inspiring to see actually what others are building on that. So for example, chest X-ray triaging and module detection by a company in the US, by Deep Health, or other response to medical staff in traditional Chinese language. It's multimodal, so we can actually use it across globally. Or summarizing progress on suggestion guidelines, aligned nudges, again, from Top Health from India, and so forth. So it's actually highly popular with over 500,000 downloads and thousands of users since launching it just a few weeks ago. So the premise here is if we put those models as platforms that others can leverage and build on, I think it's quite powerful. Now, inspired by what we did in medical information, really a lot of the future innovation is going to come from next generation. So the question is, how can we improve education? So inspired by MedPalm that we put out for medical, we actually developed LearnerLam, which is a language model based on, it's an adaptation of Gemini to actually do a better job in addressing learning-related capabilities. And in fact, just a few weeks ago, I was in Accra in Ghana in a high school that was actually testing out how can we use an application developed by a third party to help teachers with their assessment. And it was actually quite encouraging to hear from a teacher that if previously she could only provide assessment to students twice a week and it took her many hours to do that, now they're getting on a daily basis with much less time. So it's really empowering teachers. Let me try to close on one more example, which is about how to help out with AI for climate resilience. So obviously, when we think about natural disasters, about floods, about cyclones, about wildfires, these are notoriously difficult problems that actually that cost lives and economic damages. And our North Star here is really about how to have a world where no one is surprised by natural disasters coming their way. And let me just give one example, which are floods. It has thousands of casualties every year, and this is a video taken in a village that was washed by floods, overnight with casualties. I was actually visiting there just a few days after this happened. The question is, can we use AI in order to do that? Now, we had a long journey on flood forecasting, but starting with postulating back in 2018 that with machine learning we can do something about it, and actually driving the science in collaboration with some of the leading researchers in hydrology, and in a paper published in Nature showing that we can actually have a global hydrologic model that can help assisting in flood prediction. We actually put out a system called Flood Hub, which by now it covers 150 countries with 700 million people, providing up to 7 days in advance predictions. So everything I mentioned here is mostly about AI and how to use these technologies. Of course, one of the premises that we have on future technologies is how to use quantum computing, which, as we know, can unlock some problems that are infeasible with a classical computer. And, it's well known, Peter Shor's algorithm showed that you can actually solve a problem that is difficult in quantum computing. And we know that there are various problems in chemicals and physicals and molecules and others, and it's an active area of research to actually unlock more opportunities. And we're now closer than ever to actually have a practical computer. These are a couple of milestones just to mention from last year, was actually showing that we can solve in a quantum computer a problem that would take 10 septillion years to solve in a classical one in under 5 minutes, and a significant progress in error correction, which is one of the most technically difficult problems to actually solve on quantum computers. And again, these are encouraging. We have a roadmap that we are on track to actually, for what we hope to see, unlocking many new opportunities that we haven't seen before. Final note, AI is about amplifying human ingenuity. If I go back to AI Coscientist, and you think about the premises of actually having an AI system assisting you, it can be on all levels. Just imagine a world where everybody could have the like of Edison's invention factory. He was not doing it alone, he had his own factory. Take a world in which everybody could have the like of Leonardo's atelier. Leonardo as much as he was a genius, he had his atelier of apprentices. Everybody would have their own assistant on doing that. I will just close with the fact that unlike a world in computer scientists, we always think that verification is hard, generation is difficult. Looks like in the world of AI, generation becomes increasingly feasible, but knowing what's good is perhaps one of the biggest and most important questions that we have as humans. And I'll close with a quote of Duke Ellington in the world of music, that importantly in music, if it sounds good, it is good. I think one of the most important questions in every discipline that we have is for us to actually do a better job in identifying what's good. Thank you very much.